So today I'm going to talk about a certain number of math tools that you're going to need to complete the class. These are what's defined as a function, which includes the output and the variables that you input, how to read a graph, and how to convert between different measuring systems or different units. So a function is any mathematical rule that gives you an output for one or more provided variables, and variables can be any number or value which is input into the function. So for example, we have this function that is Newton's second law, that force is equal to mass times acceleration. Now, this is a function that gives us out force as an output. It tells us how much force is needed in order to accelerate something of a given mass with a constant, with an acceleration that's also given. So these are variables, and then the force is the output. So the reason that we call them variables is that they hold true for any given variable that you place in. So any given value of the variable, if you put in 1,000 kilograms or 1 kilogram or half a kilogram, it's going to tell you the relationship between mass, acceleration, and the output. So in this case, what we do is if we are given a mass m equals 1 kilogram and an acceleration, which is given by the letter a in this function, a equals 2 meters per second squared, then that is going to allow us to find the force that's needed to move a mass of 1 kilogram with an acceleration of 2 meters per second squared. So F is equal to your value here, 1 kilogram, times the acceleration equals 2 meters per second squared, which is going to be 2 times kilogram meters per second squared, which is going to be equal to 2 newtons. And then if you instead choose a mass of 2 kilograms instead, so if we vary our variable, if we choose another mass, then that's going to give us a different answer because we have changed what input goes into the equation. We have changed what output comes out of the equation. So F was going to equal 2 kilograms times 2 meters per second squared is equal to 4 kilogram meters per second squared is equal to 4 newtons, which is twice as much force. So it takes twice as much force to move an object twice as heavy as it does at the same acceleration as an object that's half as heavy as your new object. So that makes intuitive sense. That's the relationship between force and mass. And then I also want to point out that the units, when you multiplied units together, the resultant unit is kilograms times meters per second squared, because you take 1 kilogram times 2 meters per second squared. Your units are the kilogram and the meters per second squared, so the resultant unit is kilogram meters per second squared because you multiply all of them, which is equal to the Newton. So as another example, we have the equation that V average is equal to distance divided by time. So if distance is given as 5 kilometers over a time equals 30 minutes, then the V average is going to be 5 kilometers, because we plug in D equals 5 kilometers into D in our equation, divided by 30 minutes, which is going to be equal to 1/6 of a kilometer per minute. But this isn't going to be our general form that we use. Generally for velocity, we use values of meters per second instead of kilometers per minute. So in order to do that, what you need to do is find the conversion rate between one variable and the other. So in this case, 1 kilometer is equal to 1,000 meters, which means that 1,000 meters divided by 1 kilometer is just equal to 1. So that was dangerously close to doing algebra, but basically, if one value is equal to the other value, then if you divide those two values by each other, it's going to equal 1. And you can multiply 1 by anything. You can multiply anything by 1 and get the same value. So 1,000 meters equals, divide by 1 kilometer equals 1. This is also the same thing as saying that 1 kilometer divided by 1,000 meters is equal to 1. So in this case, we want to convert to meters per second. So we take 5 kilometers divided by 1 kilometer, which is equal to 1. So we can multiply this distance by 1,000 kilometers, or 1,000 meters divided by 1 kilometer, which is going to give us 5 kilometers times 1,000 meters per kilometer is going to give us 5 times 1,000 meters times a kilometer over a kilometer, which is just going to be meters times 1 kilometer divided by 1 kilometer. So this just equals 5,000 meters. And then for t equals 30 minutes, we know that, or I'm just going to give you the fact that 1,800 seconds equals, or no, never mind. I don't even need to do that. Sorry. So 60 seconds is equal to 1 meter. Not a meter, no, that's insane. 60 seconds is equal to 1 minute. So you can multiply by 60 seconds per 1 minute equals 1. So you multiply this by 60 seconds over 1 minute is equal to 1800 seconds times minutes divided by minutes, which is just going to be 1800 seconds. So going back to our equation, V average is going to be D over delta T. But this time, oh, and then I forgot to put this as delta T instead of just T, but same distance. It's going to be 5,000 meters through 1800 seconds, which is going to be a little more than 2.5, so approximately 2.6, 2.7-ish meters per second. So hopefully that made sense to you. I kind of threw you into the deep end with that second question, but if you have a number of variables, then you can change the variables however you'd like. You can put in whatever number you want for each variable, and then the function will output a force or a velocity or an acceleration or pressure or any of these types of physical quantities that correspond to the relationship between those variables and the output number that you're looking for. So the next thing that I want to do is just clear out this whiteboard and talk about reading graphs. So this is a drawing of how much, or this is a graph that tells you how much a object has fallen, y, after it's been dropped for a time t. And the equation, the formula that goes with that is that y is equal to 1/2 gt squared, where y is the output, 1/2 g is a constant because 1/2 g is gravitational acceleration, which is constant on the surface of the Earth, and 1/2 is just a number. So these aren't variables. These are just constants that change the units so that they're what you look for or what you expect. And t is our variable. So as you can see, for any given time period, this equation, y equals 1/2 gt squared, gives us a value for y for any time period that we're looking at. So for example, if you're looking at a time of 1 second, then this y value is going to be at 4.9 meters. If you look at a time of 2 seconds, then this y value is going to be 4 times as much, which is about 19.6 meters. So how you read these graphs is that whatever's on this vertical axis, whatever's on this y arrow pointing up, whatever quantity is on that axis, you go out that in a straight line, line parallel to the other axis, you go out that far until you hit the function that you're looking at, until you hit the graph, or the line that shows how the line that shows you how one variable is related to the output. So it's this function y equals 1/2 gt squared. And then that function, that value that you get, this 19.6 meters, is going to be the value that's output for your y value. So it's the output is the y axis generally. So the y-axis is what we call this vertical axis, and the x-axis is what we call this horizontal axis. So you go out a certain distance in the horizontal axis, you go up that distance until you hit the line, until you hit the function, and that's going to tell you how high up that is going to tell you what the output is for your function. And then you'll notice that I said x and y values. In this case, x is actually time, while y happens to be height, which has the same initial, or it has the same variable name as y, so that's just a coincidence. So whatever is on the x-axis is generally going to be the variable, and what's on the y-axis is going to be the output. So hopefully you've seen graphs before, even if you haven't taken algebra. They're an important part of our daily lives. You'll see graphs in the newspaper, or any infographic on line is also going to show you graphs. But hopefully it makes more sense now how to read them and like what they're telling you. So this line, for any given time, it puts out the output y. So you can just use that instead of using your formula all the time. You can just use a graph and see how it's going to relate to each other by looking at the graph itself. So the last thing that I want to do is talk about scientific prefixes, which are given on page 21 of your textbook. So basically, all of these prefixes are just simpler ways to write out certain numbers. So a kilometer is 10 to the 3 meters, which is 1,000 meters. And then gigahertz is 1,000,000,000 hertz. And I don't think we've really gone over what a hertz is, but it's 1,000,000,000 of those numbers. So whatever symbol is in front of the normal symbol that we have tells you how many of each is going to be how many of the normal unaltered units, so seconds or meters or newtons or what have you, are going to be in there. So like I said, K, little k, kilometers, stands for 1,000 meters per kilometer. Centimeter, little c, is going to be 10 to the negative 2, so 1/100th. So 1 centimeter is equal to 1/100th of a meter. So let's do a couple of easy answers. So say that you're talking about a spring and you have it compressed by x equals 5.4 centimeters. Now, what you pretty much always want to do, unless a problem's asking you to do the opposite, is you want to convert centimeters you want to convert centimeters or kiloseconds or megaseconds or whatever you have to the SI unit. So the SI unit of length is the meter, if you'll recall. So 1 centimeter equals 100 or 0.01 meters. So 0.01 meters per centimeter is going to equal 1. So x equals 5.4 centimeters times 0.01 meters per centimeter is going to be equal to 5.4 times 0.01 centimeters per centimeter, which is just equal to 1, times meters, which is going to be equal to 0.054 meters. And then for the last example that I'm planning on giving today, we're going to talk about kind of the odd child out of these SI units, where the SI unit of mass isn't the gram, it's the kilogram. So when you convert from mass, so when you convert from some other mass to the SI units of kilograms, you have to be aware that it's going to be times 1,000 times what you'd, or 1,000 times less than what you'd see if you were just solving with grams. So, for example, we have the equation, we have the function P equals mass times velocity, where P is momentum. So M in this case is, we can say, 500 grams, and velocity equals 0.2 meters per second. So momentum, which we're trying to find, is going to be, let's not even put the arrow up there to indicate it's a vector. It's just going to be 500 grams times 0.2 meters per second, which is going to be equal to 100 gram meters per second. So from here, we could convert from grams to kilograms, but I think the easier thing to do is to initially convert as soon as you see that it's not a gram or a kilogram, or it's in grams instead of kilograms, is to immediately convert this value up here. So mass is equal to 500 grams. We already have that written down, but 1 kilogram is equal to 0.001 grams. Oh, no, rather the opposite way, sorry. 1 kilogram is equal to 1,000 grams. So 1,000 1 divided by 1000 kilograms divided by grams is going to give you 1, which is just what we're allowed to multiply our mass by. So mass is equal to 500 grams times 1 over 1000 kilograms per gram is equal to 1 over 2 grams per gram times kilogram is equal to 1/2 of a kilogram is equal to 0.5 kilograms. So when we find this momentum, we want P to be equal to 0.5 times 0.2, 0.5 kilograms times 0.2 meters per second is equal to 0.1 kilogram meter per second. So that's about all I have to say. That's really all that I plan on having covering in math this semester. It's just I do reserve the right to make a change if I see that people are either floundering with this or getting or really taking to it immediately and don't have to be kind of babied the way that I could otherwise. But this is all that I'm focusing on right now. And then honestly, it isn't even about like babying or anything like that. It's just a matter of what people are able to grasp in the limited time period that we have. So I hope that this has helped you out, and I will see you again soon.